So how do you describe a data set? Here we have a data set that has four meaningful variables plus an ID variable. The four variables are age, whether or not a person is retired, their satisfaction with their retirement package, and the specific retirement package that they have. Each row here, each observation is going to be an individual person, and those four variables describe each of those folks. We also have an ID variable. So just looking at this data set with only 10 observations, you can see a lot just by sort of looking at the data. So for example, I can notice that most of the people in my data set are not retired, because under the retired category, most of those responses are 0, not retired. I can see that a lot of people are really satisfied with their retirement packages. There are a lot of 5s here, which is the highest level on our scale. But we can also see that is some variation, that there are some people who weren't as satisfied with their retirement packages. We can also see that the majority of the folks in our data set chose retirement package 1. Several people chose retirement package 3, and retirement package 2 was rare. Only one person identified that. We can also look over here at age and notice that a lot of our observations are right around the retirement age of about 65. There are some folks who are younger. We have a 52-year-old and a 59-year-old, and some who are a little bit older. We have a 73-year-old, for example. But in general, those ages are sort of clustered right around age 65, which is a typical retirement age. So in a case like this, we probably don't need a ton of descriptive statistics because we can just look at the data and talk about it and understand what's going on. But imagine that we had 10,000 observations. At that point, you can no longer just quickly skim through and see what you need to see about the data set. So we need to be able to describe each of these variables and what's going on in the variable using some descriptive statistics that will help us to understand our data and also help us to communicate about our data to other people. So the first way we're going to do that is through measures of central tendency. In other words, we want to know kind of where the middle is. What's normal? What is average? What is most common? And so measures of central tendency answer those sorts of questions. So for example, we might calculate the mean. So the mean is where you add up all of the values in the variable and then you divide by the total number of values that there were. So this is more or less like taking all of the years that people in our data set had lived and piling them all up into one big pile. It just turns out that there are 649 collective years that have been lived here. And then you divide those up equally among all the people in your data set. So we would divide that number by 10. And so our mean in this case is 64.9. Again, that's adding up all these ages and then dividing by 10 because that's how many observations we have. So 64.9 is our mean here. So if I were going to describe the age of the people in this data set, I might say their average age or their mean age is 64.9. Now, one of the challenges with a mean, though, is that if you have extreme values on either end, so for example, if we had a 104-year-old in this data set, or if there was an 18-year-old in our data set, and they're really different from everyone else, because we added up all those values and divided them up equally, it's going to be really sensitive to those extreme numbers. So because of that, we have another value that's really useful, and that is the median. And what you do with the median is you take all of the values in your data set and you put them in order. So we would start with 52 because that's our smallest value, and then we'd have a 59, and then we'd go 62, and then 63, and another 63, and 64, and then 65, and so on. So we would put them in numerical order. Once we have everything lined up in numerical order, we would identify what is the middle value. So once everything's in order, what's the middle value? And that's going to be your median. By the way, if you have an even number of observations like we do, there isn't a middle number because you have to have an odd number of observations to have a middle number. In that case, you're going to take the mean of the middle two values, which is what we had to do here. And when you calculate that, you end up with a median of 64.9. I'm running out of space here. $64.9. So, no, that's not right. 64.5. My goodness. Let's not mess that up. Okay, 64.5. That's our median. So that's the middle of our data. And then the final measure that we would use is the mode. And mode asks, what is the most frequent value? So if we look at this, the mode is going to be whatever number shows up the most often, the most frequently. And in this case, we don't actually have a lot of duplicates. If our data set was bigger, we would probably have more duplicates. But in this case, there aren't a whole lot of duplicates. But it looks like we do have two values at 63. And I think that's the only one that's repeated. So that's going to be our mode, because we have two of them. Okay, so our mode is 63. That's the most common value, but our mean is 64.9, which is pulled up a little bit by our 81 and our 73. And then our median, if you line everything up and you identify the middle one, that's going to be 64.5. So we did these examples on age. Age is an interval variable, meaning that the units between these numbers are standardized. In this case, we're counting by years, right? So a 63-year-old is 2 years younger than a 65-year-old, and that has meaning and it has units associated with it. But some of our data here isn't interval. So if you think about trying to apply these same statistics, it doesn't work in the same way. So for example, if we have a binary variable, are you retired or not, it doesn't so much make sense to like add up the yeses and the nos, like yes, you're retired and no, you're not retired. What's retired plus not retired? It doesn't have the same meaning as an interval variable. So we just don't even bother with a mean for that. Median is the same way. We can't order these in the same way that we can with interval variables or with ordinal variables. So we're not going to use a median and report that. But what we can report is the mode. So we have a binary variable, and we want to know which is more frequent, the 1 or the 0. And that's the mode that we're asking. So in this case, our mode is 0. But we wouldn't report a mean or a median. The next variable here is an ordinal variable. So here again, adding up the values and then dividing by all of them to create a mean doesn't have the same meaning that it would with an interval variable, because the distance between these 4s and 5s and 3s and 2s isn't standard. So it'd be like assuming that one person's 2 and the other person's 2 are the same value when they're not. So a mean can be a little bit misleading with this kind of data. It is used sometimes. People will calculate a mean in part because that allows them to compare, for example, the central tendency of this variable with other variables that are on the same scale, and so that can be useful. But typically when you're talking about ordinal data, the mean isn't as useful. What we want to focus on is the median. So we would put these things in order. Again, here we have a 1, a 2, a 2, a 3, a 3, a 4, and then we would put 4 5s. And then we would identify what's the very middle of that data. And in this case, the median is 3.5. And that's what we would report. If you wanted to report a mean, it so happens that that mean is 4. Sorry, you can't see that. Let me fix that. 3.5 with a mean of 4, but that doesn't have the same robustness. You're breaking some of the assumptions of that statistic when you report that. So it's better just to report the median in this case. So this last category of variables is the categorical variable, and this is retirement type. So which type of package do people have? And there are 3 discrete options. And let's just assume for the sake of this example that they can't easily be ordered. Like people have made trade-offs about like when they get their retirement money and how it's being invested and that sort of thing. So it's not like they can be ordered in some kind of way. So these numbers are really just describing package names. Like this is package 1, the optimum package, and this is package 2, the platinum package, and this is package 3, the awesome package. So we can't order those in the same way. Also, the numbers don't actually mean what numbers usually mean. In other words, they're not counting anything. In this case, they're just names. They're names for categories. Even though they look like numbers, they don't behave like numbers. So we don't want to add these numbers. Again, an optimum package plus a platinum package doesn't mathematically make sense. So we need to be careful not to treat these numbers as though they are unit numbers. These are just name numbers. So because of that, we can't calculate an average. It would be completely meaningless. We don't want to do that. No mean. And we can't put things in order, so we can't find the middle item. So we can't do a median either. So in this case, like with the binary variable, what we want to do is identify the most common or the most frequently indicated value. And in this case, that would be a mode of 1. The other thing you can do is figure out what the percentages are for each of these things. So you could say, for example, it looks like we have 6 people who chose package number 1. In this case, that's 60% of people chose package 1, 10% chose package 2, and the remaining 30% chose package 3. So you could report things like that. You just want to be careful to avoid the mean and the median. So that all describes central tendency. And again, we can describe like in our data set, and again, imagine we have like 10,000 observations. So we couldn't just look at the numbers and talk about this. We can now say the average age of people in our data set is 64.9. Most of them are not retired. In general, they're really quite satisfied with their retirement packages. We have a median of 3.5, so that's better than neutral, which would be 3. And we can say that most people in our data set, in fact, it was 60% of people in our data set, chose package 1. That helps us describe the whole data set, even if we couldn't look at each individual observation. The other thing we want to do is talk about how spread out the data are. So there are a few things that we use for that. One obvious thing is to identify what is the highest value and what is the lowest value. That doesn't make sense for categorical. Doesn't super make a lot of sense for binary because there are only 2 options. So one's going to be the highest and one's going to be the lowest. And typically they're going to be 0 and 1. So most of the time that's not useful information. But we are interested in what the highest and lowest values of our ordinal data are and what the highest and lowest values of our interval data are. So in this case, the lowest value for retirement satisfaction is a 1, and the highest value is a 5. The lowest age here was 52, and the highest was 81. And so that gives us an idea of like, what are the ages of people we're talking about, and what is the overall satisfaction of people that we're talking about? Like, what are these ranges? There's another statistic that's helpful for interval level data, and that is the standard deviation. And I like to think of the standard deviation as the average distance from the mean-ish. The math works out so it's not actually an average distance from the mean, but it's close and the meaning is very similar. So what does that mean? Well, one of the questions we might have about our data is, well, I know that like the middle of the data is right around 64, 65, but are the ages close to that? Are they like clustered together right around that age of 64.9? Or are they really spread out? In other words, do we have like 18-year-olds and 20-year-olds and 102-year-olds in our data set? Do we have a nice wide spread? Or do we have a beautifully tight distribution where most people are really close to that mean? And so by calculating the standard deviation, that helps us to talk about how spread out the data is or how clustered around the mean it is. And so the way you calculate that is you figure out what the mean is, and then for each observation, you figure out how far away that observation is from your mean. So how far away is 63 from 64.9, and it's 1.9 years. How far away is 65 from 64.9? It's 0.1 years away. So for each of these, you would figure that out, and you can do like if it's above or below the average with plus or minus signs, but in the end you end up squaring that so that goes away anyway. So you're really just trying to figure out how far away are each of these from the mean. And then you're going to divide that by the number of observations there are here, minus 1. That's why it's an ish. So you're going to divide that by how many there are. So again, we're collecting how far away is each individual. And then if we spread that all out evenly across the individuals, how far on average are they from each other? So again, in the formula, you would then take the square root of the whole thing, again, ish. But I want you to think about it as the average distance from the mean, ish.